Hello everyone. In this video, we will discuss about the solution for the question number 44 that was asked in 8 2023 in electrical. So the question is from analog electronics, and uh, we are given a circuit in which there are three diodes, two current sources, and three voltage sources with one switch, and we have to find which are the diodes that are reverse biased or forward biased according to the position of the switch. So this is actually a multiple choice, multiple correct answer question. So two conditions are given, like when switch is on, two options are there. When switch is off, two options are there. So we have to evaluate uh, which are the correct options by analyzing the circuit. So let's go to the solution. Here, what we have to do is we have to make some assumptions and solve the circuit. That's the basic procedure for this solution. And finally, we will check whether our assumptions are correct or not. If our assumptions are incorrect, then we have to make another assumption. That means in the circuit, we don't know which are the diodes are forward biased or reverse biased. So we will assume certain diodes are forward biased and reverse biased, and we will solve the circuit, and we will check if our assumption is correct. That is, if the after solving the circuit, if the diodes are forward biased or reverse biased, that we will check. If our assumption is correct, then we can proceed with that, or otherwise we have to go for another assumption. So we can have two cases here, that is, one is switch on, another one is switch is off. So first case we will consider it as switch on, and here when switch is on, we will have this configuration, and from the observation itself we can see this diode D3 is reverse biased because this potential is lower than this potential. So we can say this diode D3 is reverse biased, so it is turned off. So we can simplify the circuit like this, and here we are going for our assumption. The first assumption that I am considering is D1 and D2. D1 and D2 both are off because we don't know which is off, which is on. So we are going for some assumption. So we are assuming D1 and D2 are off. So in this case, the circuit will be like this. And if you are checking the circuit, we can see the KCL is violated. That is, you can see, considering this point, there is 4 ampere entering, but the current leaving from this point is 0. That means KCL is violated in this point. So this is not a possible scenario. That means our assumption is wrong. That is, D1 and D2 both can't be turned off at the same time. So our assumption is wrong. Now we will go for the next assumption. We will go for the next assumption, that is D1 is on and D2 is off. So going back to the question, we are assuming D1 is on and D2 is off. This is the assumption that we are considering. So our circuit will be like this. D1 is on and D2 is off. Here if you are checking, KCL and KVL are not violated because whatever the current entering at this point is leaving through this branch. Whatever the current entering this point is leaving through this branch. So KCL is not violated, and also we can apply KVL in this loop. We can apply KVL in this loop. So KVL also not violated. That means, okay, regarding the basic things, it is fine. Now we have to check the assumption. What was our assumption? D2 was turned off. So that we have to check. How we can verify that? Like, we have to check, verify the voltage at A and B. If the voltage at A is lower than the voltage at B, that means this is reverse biased. Otherwise, it is forward biased. So our assumption was this is reverse biased. So what we have to get is the voltage at B should be greater than voltage at A. This is what we have to get. Voltage at B should be greater than voltage at A. Then only this will get reverse biased. So that you have to check. So we will check voltage at A. What is voltage at A? It is connected to the ground. So voltage at A is 0. And then voltage at B. Voltage at B is connected to this 20 volt source. So voltage at B is equal to 20 volt. So by solving the circuit, we can see that D2 is reverse biased when D1 is on. So our assumption is correct because here we could verify the voltage at A is less than voltage at B. That means this is reverse biased and that is our assumption. So our assumption is correct. So we can say when H is on, that is this switch is on, D1 is on and D2 is off. That we can confirm. So that is what I have written here. When S is on, D1 is conducting and D2 and D3 are reverse biased. This is for option B. So for the first case where S is on, we can have this condition where D1 is conducting and D2, D3 are reverse biased. Now we will go to the next case where the switch S is open. So when we are then our circuit will be like this. Again, from the observation we can see the current is passing through this, right? So this current will not go this, but it will pass through this, right? That means this current always pass through this point. That means D3 is always on. So D3 is always on because this current has only one path, that is this path. So D3 will be always on. That we can confirm. Now, one thing we have confirmed. Next thing are D1 and D2. Now we will go for some assumption. So for the first thing I am assuming that I assume D1 is off and D2 conducts. D1 is off and D2 conducts. Then our circuit will become like this. So here also KCL and KVL are not violated, okay? Because whatever current entering this point, you can lead through this one, this circuit or this branch. We can apply KVL here, we can apply KVL in this loop. So the KVL is not violated and KCL is also not violated. So now we have to solve this circuit and check whether our assumption is correct or not. What was our assumption? D1 is reverse biased. That means A is having less potential than B. So we can check the voltage at A. Voltage at A, that is, it is connected to 20 volt. So voltage at A is 20 volt. Voltage at B is connected to 40 volt. So voltage at B is 40 volt. What does that mean? Voltage at A is lower than voltage at B. That means this D1 is reverse biased. So that is our assumption also. Assumption itself is that D1 is reverse biased and after solving the circuit, we are getting the same. So that means our assumption is true. So we can verify here. We can stop the procedure here. We have verified that for switches off, D1 is reverse biased, D3 is forward biased, and D2 is also forward biased. So D1 reverse biased, and D2, D3 conducts. So that is option C. So the two answers are correct answers are, we can see one is option B and another is option C. So the correct answers are B and C. Here we are using assumptions. We will make some assumption, we will solve the circuit and we will check whether assumption is true or not. If the assumption is true, then we can proceed with that assumption. If the assumption is wrong, we have to change the assumption. We have to go for another assumption. That is how we are solving this problem. And more about the diodes and its circuit, I will recommend you to go through this lectures. So that's all about the answer. Thank you.